The image below shows a satellite orbiting Earth. The satellite passes directly over two tracking stations, A and B, which are 64 miles apart. When the satellite is on one side of the two stations, the angle of elevations at A and B are measured to be 78.1 degrees and 86.4 degrees respectively, which are labeled in the diagram. Let's go ahead and complete the diagram. We know that stations A and B are 64 miles apart, and therefore this side of the triangle is 64 miles. Let's go ahead and label the vertex where the satellite is vertex C. And then from angle A, the opposite side is side A. From angle B, the opposite side is side B. And we know side C has a length of 64 miles. Part A, we're asked to determine how far the satellite is from station A, which is the length of side B. And then part B, how high is the satellite above the ground? To do this, we'll have to form a right triangle that's related to the given triangle. Let's first answer part A by determining the length of side B. We first need to determine the interior angles of the triangle. Notice 86.4 is supplementary to the angle B of the triangle, and therefore we can find angle B by taking 180 degrees and subtracting the angle of elevation of 86.4 degrees, which gives us 93.6 degrees for angle B inside the triangle. And now because we have two of the three interior angles, we can find angle C by taking 180 degrees and then subtracting the sum of the other two interior angles. So 180 degrees minus the sum of 78.1 degrees and 93.6 degrees equals 8.3 degrees. And now because we have the measure of angle C and the length of the opposite side, as well as the measure of angle B, we can use the law of sines to determine the length of side B. The sine of angle B, or the sine of 93.6 degrees, divided by the length of side B, which is unknown, equals the sine of angle C, which is the sine of 8.3 degrees, divided by the length of side C, which is 64 miles. And now we need to solve for B. Let's go ahead and cross multiply, which indicates B times sine of 8.3 degrees equals 64 times the sine of 93.6 degrees. And now to solve for B, we divide both sides by the sine of 8.3 degrees. Simplifying, sine of 8.3 degrees divided by itself simplifies to 1. We have B equals 64 times sine of 93.6 degrees divided by the sine of 8.3 degrees. And now we go to the calculator, and we are told to round to the nearest whole mile. We have 64 sine of 93.6, close parenthesis, divided by sine of 8.3. Enter. Because of the tenths place value, we round down to 442 miles. To the nearest mile, the satellite is 442 miles from station A. And now for part B, how high is the satellite above the ground? We can't use this triangle to determine the height because this is not a right triangle. The length of side A is not the height. Let's sketch a right triangle that would show the height of the satellite. For this right triangle, we'll let this vertex be vertex A and this vertex be vertex C, which is where the satellite is. We know the distance from the satellite to station A, or the length of the hypotenuse, to the nearest mile is 442 miles. We also know angle A is still 78.1 degrees. And the opposite side of angle A, this side here, would be the height, or the distance that the satellite is above the ground. And because we have a right triangle, we can use right triangle trigonometry to determine the length of side H, or the height. In relation to the angle of 78.1 degrees, H is the opposite side, and we have the length of the hypotenuse, and therefore we can use the sine function to determine h. The sine of 78.1 degrees must equal the ratio of the opposite side to the hypotenuse, which is h divided by 442. To solve for h, we multiply both sides by 442. Simplifying on the right side, 442 divided by itself simplifies to 1, giving us the height h equals 442 times the sine of 78.1 degrees. And now we go back to the calculator, and again round to the nearest mile. 442 times the sine of 78.1 to the nearest mile is 433 miles. To the nearest mile, the satellite is 433 miles above the ground. I hope you found this helpful.